In this video, we're going to have a look at parallel and perpendicular lines. We're going to start off with drawing a few equations. Okay, so we have y is equal to x. I already made a little table. So that means when x is minus 4, well, very simple, y is also minus 4. When x is minus 2, y is also minus 2. When x is 0, y is 0. When y is 2, when x is 2, y is 2. When x is 4, y is 4. Let's plot those on the graph. Minus 4, that's here, here, here. I'm plotting a few extra points, guys, because it's obvious that this line is just going to go like that. Okay, let's plot that line. And again, you guys can be a lot more accurate with your pencil. Voila. Okay, so don't forget, label that graph. This is y is equal to x. Let's have a look at the other one. Y is equal to x plus 4. Okay, so when x is minus 4, we get y is equal to minus 4 plus 4, which is going to be 0, obviously. Then, when x is minus 2, y is going to be minus 2 plus 4, which is 2. And so on and so on. Let's add that, yes, and then you get a certain amount of coordinates. Minus 4, 0, that's here. Yeah. Minus 2, 2, minus 2 and 2, that's here. 0, 4, that's here. 2, 6, over there, and 4, 8, over there. Okay, let's plot that. Yeah, don't forget to label. This is y is equal to x plus 4. Let's have a look at the other one. Y is equal to x minus 2. So when x is minus 4, we get minus 2 minus 4. Minus 4 minus 2 is minus 6. When it is minus 2, we get minus 4, minus 2, 0, 2, and so on and so on. Voila. So let's plot those as well. Minus 4 is minus 6, so that's here. Minus 2, 4, minus 2, minus 4, like that. 0, minus 2. And then you have 2, 0, 4, 2. And that's here. If you plot that line, what do you get? Yeah. Almost. Let's make it a bit more clear. Yeah, I like that. Okay. Then, let's have another look at that. It's not really clear. It's not. Now it's correct. Okay. Now, don't forget again to label your lines. This is y is equal to x minus 2. All right. Now you have 3 lines on my graph. As you can see, all 3 of these lines are obviously parallel. But when we have a look at the equations, there's also something that pops up. We always have y is equal to x. Y is equal to x plus 4. Y is equal to x minus 2. So those x's are the same. So that means the coefficient in front of x is the same. We always have 1 in this case. So what we see is that the gradient, or m, is equal to 1 in all 3 of these equations. That means that when lines are parallel to one another, they must have the same gradient. Other way around, when equations have the same gradient, when the same m, those lines must be parallel. This is one of the first things that you can deduct from this. So equations with the same gradient always are parallel to one another, as you can see here. All right, let's have an example exercise of that. The equations of 4 lines, you can list them below, so you get 4 of them. Which line is parallel to A? Let's have a look. A here has an m, or a gradient of 3, so that means that you're looking for other equations with the same gradient. Okay. Oh, which line is parallel to C? Or to A? Sorry. Obviously C. B and D cannot be parallel because 4 is not the same as 3. So that's an easy option, or that is an easy answer here. Which line is parallel to A? Only C. Now, which line is parallel to B? Obviously, B has a gradient of 4. We're looking for the same, and that's obviously in D. So B and D will be parallel, while A and C will be parallel as well. This is a quick trick. Without even having to draw your lines, you can now see which ones are going to be parallel. Now, we're also going to have a look at perpendicular lines. If you don't know what perpendicular means, it means that those two lines will intersect at an angle of 90 degrees. So here, you know that these two are perpendicular lines. This angle here is 90 degrees. That's what it means. All right, let's have a look at question A. You have to calculate the gradient of line A, and you have to write down the equation. All right, so it's not really difficult. We've done this before. All right, gradient here. All right, and this actually it asks to calculate, so you can have two options. You can pick two coordinates. So we have 4, 1, and I have 7, 7. All right, you know that m can also be calculated by calculating the difference between your two coordinates. So we have 7 minus 1 over 7 minus 4. Be careful, this is my second coordinate, this is my first coordinate. So 7 minus 1 is, no, not 8, Miss G, not 8, that's 6. 7 minus 4 is 3. So the gradient should be 2. Now I have my gradient. Now I need to write, they're also asking me to write down the equation. I know it's going to be y is equal to 2x plus c. What is my c? Let's have a look on my graph. My c is obviously 1. Not 1, minus 7. So y is equal to 2x minus 7. That's the equation of the first line. Let's have a look at the second one. Calculate the gradient of b. And again, I'm going to pick two coordinates. As you can see, this here, I'm going to pick a very wide range. This line here, b, is obviously not a line that will go up. It goes down. So you will have a negative gradient. Your gradient has to be negative. Let's have a look. I have my first coordinate here, that is minus 8, 2. And I have my second coordinate here, which is 8 minus 6. Alright, if I calculate my gradient now, and again, I'm just going to calculate. I'm not going to use the rise over run, but I am going to use the calculation. It's finding the difference between the two coordinates. y2, so this is this, minus 6 minus 2, and this is 8 minus 8. Minus 6 minus 2 is minus 8. And then 8 minus 8 is going to be 16. So what do you get? You get minus 1 over 2. Alright, so this is now your gradient for line B. Now, you have to also write down the equation. You have the gradient already. So let's have a look where my y-intercept is for B. My y-intercept is right over here. So the equation is going to be y is equal to minus 1 over 2x minus 2. Alright, now I'm going to have a look at the two gradients of these equations. So I have minus 1 over 2 and 2. Alright, how are they related? Well, this might be a bit tricky to see at first, but so we have m1 or m of a, so the gradient of a is 2, and the gradient of b is minus 1 over 2. What happens is the following. For lines that are perpendicular, your two gradients, when you multiply your two gradients, in this case minus 1 over 2 and 2, you should always get 2 times minus 1 over minus 1. So that's one of the things that you should remember as well about perpendicular lines. When lines are perpendicular, their gradient will always multiply to minus 1. Okay, that will always be the case. You could also put it in a different way. You could say, and I'm going to show you a grid now for perpendicular lines. You could say that if two lines are perpendicular, you know that the gradient or the two gradients will multiply to minus 1. Or you can say gradient of B is minus 1 over the gradient of A. So both will be fine. Okay, but you have to remember, so parallel lines have the same gradient, while perpendicular lines have two gradients that multiply to minus 1. Knowing all of this, you can now solve this question here. Very interesting question. Line A has an equation of 3x plus 2. Write down the gradient of line B that is perpendicular and also has to be a possible equation for that line. All right, you now know that B has to be perpendicular, okay, to A. All right, so what do you know? M of B is going to be minus 1 over the gradient of A. What is my gradient of A? That's 3. So I'm going to get minus 1 over 3. So the gradient is going to be minus 1 over 3. Do we know anything else about that line? No. The only thing I know is that my gradient has to be minus 1 over 3. But any equation with a gradient of minus 1 over 3 will be perpendicular to that line anyway. I don't care where that line will be. For example, if I draw A here, like that, any line perpendicular to that, or any line with a gradient like this, will always be perpendicular. It doesn't matter. So I am going to write down the equation for B, and y is equal to minus 1 over 3x. You know what? I can say, oh, plus 3. Or y is equal to minus 1 over 3x plus 2. Or y is equal to minus 1 over 3x minus 7. And so on, and so on, and so on. It really does not matter. Okay? Alright, good luck on the exercises, guys.